In the last class, we have studied about constructing a PDA for the language L equal to A power n, B power n such that n greater than or equal to 1. So in this class, we are going to study about the transition function for this problem and also the instantaneous description method for accepting a string. So the transition function delta equal to, how can we write the transition function? Initially it is in the state Q0 and we are reading the input symbol A, and what is in the top of the stack? It is Z0, right? So equal to, it is going to the same state Q0, and what will be in the stack? A Z0. Okay. So in that manner we have to write the transition function. Okay. We are going to read W equal to A, B, B, B. Okay. So initially Z0 will be there, and now we are pushing A into the stack. And then how can we write the next transition function? From the transition diagram also we can write this. So next, it is in Q0 only, and then again the input symbol is A, and what is in the top of the stack? It is again A equal to, it is going to the same state Q0. A will be in the stack, that is top of the stack and previous top of the stack and the input that is pushed. Now this A is in the top of the stack. And the next transition is again Q0, input that is reading us this A, and then top of the stack is A, and so no need to write it again. Anyway, for understanding I am writing it again, and then both are same only because we are reading the same input and same items are in the top of the stack. Okay, both are same only. And then after reading all the symbols of A, it's moving on to the next state, that is when it is in Q0, while it's reading the symbol B, and now the top of the stack is A, so it's going to the state Q1. While reading the input symbol A, it's going to the new state, that is Q1. And now what is in the top of the stack? So what is actually happening is, now while we are reading the symbol B, one A will be popped. That is our logic, right? When we are reading a B, one A will be popped out. So for mentioning this popping, we are giving this symbol epsilon. Okay, and then next is again the same transitions. Q1, it is in state Q1 and the symbol to read is B, and then what is in the top of the stack? Again A is in the top of the stack, so it is popping out. While reading the symbol B, it is popping out. A is popping out. Okay, and then delta of again Q1 comma B, the symbol to read is B, and now A is in the top of the stack, and at that time we are popping it out. So all the three A's are popped out and we are having Z0 in top of the stack. Okay, so next transition is Q1, and what it is reading now, after completing all these three B's, we are having epsilon. Okay, so we are reading epsilon, and what is in top of the stack? Z0. I already said that while we are seeing an epsilon and Z0, we have to understand that we reach to the end of the string. We are completely we have read the we have completed reading the end of the string. Okay, so now we know that the string will be accepted in two ways, right? Emptying the stack or reaching the final state. So how can we reach to the final status? So at the top of the stack, that the z0 will be remain there. So if z0 is remaining there, means we can reach to the final state qf, and top of the stack is z0. Okay, so now we reach to the final state. And another one method for accepting the string is here, while we are seeing this epsilon and z0, we can pop that epsilon out also. So this is another one method. In that case we are having the state q1, and while we are popping this z0 out, we are having epsilon, nothing is in the stack. Okay, so this is acceptance by emptying the stack. Okay, so this is the transition function for this particular problem. And now we are going to study about instantaneous description. How can we from the language a power n, b power n, how can we say that a string is accepted using PDA? So we are now going to use the instantaneous description method for accepting a string. Okay, so our string is w equal to a b b b. Okay, so what is the starting state? q0. What is our string? A. This is instantaneous description method. So what is our string? A b b b. Okay, and top of the stack is z0. Then we are writing the turn slide symbol, then q0, and we are pushing one symbol into the stack, that is a z0. So this is in the stack. A z0 is in the stack. Now this is our string and this is the state. And after this, it's again going to the state q0, and again a b b b. Okay, so we are pushing another one a into the stack, this a into the stack. Now we are having two a's in stack with along with this z0, and then q0. Again we are going to read this a and we are going to push it into the stack b b b and a z0. Okay, now we know that while seeing a b, we are going to pop on a from the stack, right? Also we are changing the state also. We are going to another one state while reading this b, q1 b b. We are reading this b, so we are going to pop this one a from the stack. So we know that lost in first out is the stack operation. So here you can see we are going to pop this a out and a z0, and then q1 b, and while reading this b we are going to pop another one a. Okay, a z0, and then q1, nothing to read in the string. So epsilon, we are going to read this epsilon only, epsilon, and what is in the top of the stack? It is z0. Okay, now we can understand that. Okay, so here also we can show it by reaching to the final state. So if it is going to the final state, and we know that while seeing an epsilon and z0, we know that this it reaches to the end of the string. That means the string was accepted. So qf, that is final state, it reaches to the final state, and what is in the top of this, it is reaching to the final state. So the acceptance of a string using the final state. So Z0 will be in the top of the stack. So acceptance by final state. So how can we write the acceptance by emptying the stack is Q1 and Q1, and we are going to empty this, we are going to pop this Z0 also out while reading this epsilon. So in that manner we are getting nothing inside the stack Q1 epsilon. So this is acceptance by empty stack. Okay, so this is the instantaneous description for this particular problem, that's a power n, b power n. Okay, thank you.